Okay, so I'm going to do a quick video there just explaining standard deviation. And this symbol here, sigma, is what represents standard deviation. Okay, so in order to understand how standard deviation works, we need to have a fair understanding of averages. So your averages there are your mean, your mode, and your median. Okay, your mean is the most common one. So that's just where you take your set of data, you add all the values or all the inputs, and then you divide by the number of inputs. So for example, if you had this set of data here, you had 3, 4, 4, 2, and 7. If you were to get the mean for that set of data, what you'd need to do is you need to take those numbers and you'd need to add all the values. So add 3, 4, 4, 2, and 7. So you can see that we've done that here. Okay. And divide by the total number of inputs. And there was 1, 2, 3, 4, 5. So we divide by 5. If we were to add them together and divide by 5, we would get the number 20 divided by 5. And 20 divided by 5 is equal to 4. So the mean for this set of data would be equal to 4. So next what we'll do is we look at the mode, okay? And the mode is the most common or the most frequent. So if we look at this here, we'll need to pick out the mode. Now, the mode being the most common, so you can see here that the number 4 is the most common. So in this case, the mode would be 4. That then brings us on to the median. And the median is the middle value once all of the data is in order, right? And that means going from smallest to largest. So I'm just going to rearrange this and say 2, 3, 4, 4, and 7. Now you can see I'm going from smallest to largest. And the middle number there, in order to find out the middle, take one from each side, take one from each side. So the middle there would be 4. So obviously the median would be 4. So I'm just going to go through a second set of data there, which is 3, 3, 4, 2, 7, 8. And the reason why I'm going through this is because you'll see that this has an even set of inputs, or even set of numbers, you could say. So when I put this in order, I'll end up with 2, 3, 3, 4, 7, and 8. Okay. And to find the median for this set of data, I do the same thing, cross one from the smallest and cross one from the largest. One from the smallest, one from the largest. And you can see there I'm left with 2 numbers, okay? So in this case, if you're left with 2 numbers in the middle, in order to find the median, what you do is you add those 2 numbers. So 3 plus 4 equals 7. And to get the middle of those 2 numbers, you just add them and divide by 2. So we divide that 7 by 2 and we'll get 3.5, okay? So anytime you're getting the median and you have 2 numbers left in the middle, just add those 2 numbers and divide by 2. The last thing to cover here is just that there is some small little tips to help you with this. To differentiate between mean, mode, and median. MO for mode, MO for most frequent or most common. Okay. And median starts with M and has an I in the middle of it. And middle is obviously MI for middle. Okay. The mean is the one that you kind of use the whole time because you've been doing that to get your result and test scores and stuff. So the mean you should be most familiar with. The mode, MO for most, MO for most common. And median obviously has an I in it, and middle. Just make sure that the data is in order. Okay. That brings us on here to the measure of spread, right? So the measure of spread is basically just measuring how spread out data is. Okay. So we need to be familiar with the range. Okay, which is the biggest number minus the smallest number. And we need to be familiar with the interquartile range. So that's just where we take the data and we divide it up into quarters. Okay, and we say the third quarter minus the first quarter is the interquartile range. And that's basically just giving us this range here. Okay, so what that does is it gets rid of outliers. Okay, and we'll see that when we go on to the next section. Okay, so what we're going to look at next is standard deviation. Okay, standard deviation is the third way that we can use spread to measure data, right? So this is another way of analysing the spread of data, okay? So what I'll do is I'll just talk you through this question and this will build up an understanding of it, and then we'll be able to go on and try some questions. So start by comparing the results of 7 students from 2 different classes. Both are classes of 30 students, okay? So we're just taking 7 students from each class. Class A, I've picked these 7. Class B, I've picked these 7, right? If I want to compare their scores, typically what I do is I probably find an average, okay? So an average, or the mean is probably the best average to use, right? So the mean is the average that I typically use, okay? The next thing that I need to do is get a sample mean, right? So a sample mean, that's just a symbol they use for a sample mean. But basically all that means is we want to get the average. So how I get the average, and you know how to get the average, the best average to get there is probably to get the mean. So in order to get the mean, I'd have to take all these numbers here, add them together and divide by 7 because there's 7 different inputs. Okay, so the mean for the first one there is going to be 70. So if you added all their scores like I did and divide by the total number of inputs, which is 7, you would get a mean of 70. In order to compare these two classes, I need to get the mean for the second one. Okay, and you can see there, if I got the mean for class B, I add all these together and divide by the total number of inputs, which is 7. And that gives me a mean of 70. So the mean of these two classes is both going to be 70. Now, from looking at that, we need to decide how helpful that actually is. So the mean here for class A, the average in class A is 70. The average in class B is 70. But if you go back and look at their actual scores, you can see that these ones ranged a lot more. So there was a bigger range. These were more spread out than these ones. Okay. So that brings us to here. So here now, what we've got so far is we've got the mean for the first class, or class A, being 70, the mean for the second class being 70. And like I just said, what we need to start doing is we're going to start looking at the spread of this data. So in order to find out the spread of this data, what I'd need to do is I'd need to find the range. Okay. So we know that the range is the biggest minus the smallest. So the range for the green one will be 73 minus 67. So 73 minus 67. So that tells us there that the range is going to be equal to 6. Okay, because the largest number, 73 minus 67, that's what we've done to find the range, the biggest minus the smallest, and that gives us an answer of 6. So this data here ranges by 6. Okay, so we need to get the range for the pink one, or class B, and the range for class B is the largest minus the smallest, which is 100, take away 40, and it's 60. So I can see that this data is spread out by 6 marks, whereas this data is spread out by 60 marks. Okay, so that gives us our two ranges there. So we can start to make assumptions between these two classes. We can start to make conclusions. So it seems like this class here all seem to be about the same level, around 70, whereas these ones here seem to be spread out more. Okay, so to help further develop our understanding of spread, what I'm going to do is I'm going to add this third class here. Okay, now I want you to look at the data in the third class and see how that links in with the other two classes. Okay, I filled in the mean again of 70, so the mean is the same. The range, obviously the range for the first one was 6, the range for the second one was 60. The range for the third one will be 100 minus 40, which is 60. So that would suggest that these two classes, they have the same mean and they have the same range. So that would suggest that the marks scored in this class and the marks scored in this class are very similar. Okay, but that's when we need to start thinking in terms of standard deviation. Okay, so standard deviation, what we're going to do is we're going to find how much these marks deviate from the mean, right? So deviate from the average. And we know the average in each of these cases is 70. Okay. So how can we compare these three classes? Okay, so first thing we need to do is we need to consider how far they differ from the mean. So that's what I was just saying there. So we need to see how far these classes differ from the mean. So if we look at the green ones there, the first class A, we can see that the green ones all differ from the mean. So the mean was 70. So if I wanted to get how far that differs from the mean, it's going to be less. So it's going to be 3 less. 68 is 2 less than the mean. The mean is 70. 69 is 1 less than the mean. 70 is 0, so that doesn't change at all. 71 is 1 greater. 72 is 2 greater. And 73 is 3 greater. Okay. We now need to look at class B. How do those results differ from the mean? So if we look at class B there, we can see that 40 is 30 less than the mean. 50 is 20 less than the mean. 60 is 10 less than the mean. 70 is 0, obviously. 80 is 10 greater than the mean. And 90 is 20 greater. 100 is 30 greater. Okay. We can then look at class C and see how far they differ from the mean. So in class C, we can see that these differ from the mean by 30. So it's 30 less. none of these, they're all the same. So they're all the mean basically. So then we need to look at 100, and 100 is obviously 30 greater than the mean. Okay. So what we need to do, so x represents the number that we had. So that was here. And how it differs from the mean gives us this. But the only thing is, these are positive and negative values, right? So these are positive and negative values. So in order to get them all positive, we need to just square them. Okay, so we need to square these differences. Okay, so if we square those differences, and say we wanted to get an average for these, if we squared all of them, added them together to get the mean, and divide by the number of inputs, which is 7, then we'd have close enough to what we're looking for. So let's start by looking at this one. So if we take the first class, if we took how far they differ from the mean, so these differ from the mean by 3, 2, 1, 0, 1, 2, and 3. If I was to take the 3, negative 3 and square it, and if I was to take the negative 2 and square it, take the negative 1 and square it, take the 0 and square it, take the 1 and square it, 2 and square it, and 3 and square it, if I was to do that and get the average by dividing by the number of inputs, dividing by 7, I would end up with an answer there of 4. So I'm basically finding the mean gap between my terms, right? So it's the mean gap between my terms. Now, the only thing is, I squared all of these here. So when I get my final answer, I need to get the square root to get it back to what it should be. So if I got the square root of 4, standard deviation for the first one will be equal to the square root of 4, which is 2. We'll now have a look at the second one. And the second one, what we needed to do is we needed to look at how far these deviate from the mean. Okay, so in order to find out how far they deviate from the mean, we just calculated it. So the mean was 70, so 40 is obviously 30 less, 50 was 20 less, 60 was 10 less, 70 was on where it should be, 80 was 10 more, 90 was 20 more, 100 was 30 more. So we can see how much they're deviating from the mean, but the only thing is, we can't use positives and negatives. So we can't get an average of these with positives and negatives. So what we need to do is we need to get the average by turning them all into positives, by squaring them. So square them all, add them together, and divide by 7 to get an average. Okay, so I squared the 30, the negative 30, squared the negative 20, squared the negative 10, squared the 0, squared the 10, squared the 20, and squared the 30. So I just got an average of their gaps, right? So when we squared them, we ended up with a mean gap of 400. So it's an average gap of 400. But what we need to remember there is that we ended up squaring all them. So in order to get the standard deviation, we need to get the square root. And the square root of 400 is going to give us an answer of 20. So that then brings us to the last class, class C. Okay, and class C, their marks were given like this, and we could see that was 30 less than the average. The mean, these were all the mean, so they're all equal. And this one was 30 more than the average. So, like I said, in order to get the average of these, what I need to do is make them all positive, first of all, by squaring each of them. So I square these and add them together. So if I square them all and add them together and divide by the total number of inputs, the total number of inputs in this case was 7, and I get an answer of 257.1428571. The only thing is, I've done everything there. I've added them all together and I divided by the total number of inputs. The only thing I didn't do is get the square root. Because I squared them, I need to get the square root. So if I get the square root of 257.1428571, I get an answer of 16, okay, 0.0356. So that's that done, right? So what we found there is we found an average for how far they deviate from the mean. So if you were to look at this, a good class stair would have a high mean and a lower standard deviation, okay? So a high mean and a low sigma. So you can see these ones here are far more tightly compacted than we'll say these ones here, which are more spread out, and these ones here, which are even further spread out, okay? So we want to keep our standard deviation low and we want to keep our mean high in order to have a good class, you could say, right? It's important that you understand for leaving cert ordinary level, you need to be able to use this formula. But there's an easy way of doing it, and that's just from using the calculator. So if you can use the calculator to find sigma or the standard deviation, then I just need to be able to show you how to use the calculator. So you don't actually need to be able to go through all these steps. You can just simply input all this information, okay? Input the information that you started with straight into the calculator, and I'm going to show you how to do that now. Okay, so we're going to start there with, we've got the list there of marks that 7 students got in the class, and we're going to find the standard deviation using the calculator. So all we need to do is we just turn on the calculator, okay? We see there that we're in the degree modes, okay? So that's good. And what we need to do is we need to be able to input all this into the calculator. So we need to be able to input all this into the calculator. So we start there by pressing menu, okay? And we go across there to option 2, which is statistics, which we're studying, and we press equals, okay? We then go into one variable, so that's the first one there, which is one variable. So press 1, and then we input all this information here. So I need to input the 67, the 68, the 69, the 70, 71, 72, and 73. So I just press 67, and I press equals. I press 68, and I press equals. Next one there is going to be 69, and equals. Obviously 70 is next, and equals. 71 is next, and 72 is next, and press equals again, and finally 73. And you can see there that that's going to be the third piece of information, or the 7 pieces of information. So I've got 7 pieces of information in. I've got 7 students that I'm looking at. So once I've done that, I now need to see all the information has been input. Now I need to get the calculator to calculate it. So press options, and then go to one variable calculations, which is option 3. And that will tell you all of this here. So it'll tell us the mean of 70. It'll tell us the standard deviation of 2. Okay, so the standard deviation in this case, sigma was equal to 2. So that was the standard deviation for class A. If I want to get the standard deviation for class B, what I need to do is I need to clear all this. So I'll AC for all clear, and I'll clear it all again. It's probably best to even turn off the calculator and turn it back on. Okay, so the on button there, and we're going to start again. So we're in statistics, one variable, which is what we want to be, and we're going to have a look there. So menu, statistics, one variable, which is 1, and input the data again. So we'll have 40 equals 50 equals 60 equals 70 equals 80 equals 90 equals and 100. And again, that was all of the data. Okay, so that was all of the data that we had in the second class, 40 to 100. Okay, so we have our 7 pieces of data input. We can see this number 7 there. So now we need to get the calculator to make those calculations. So again, we go to options, we go to one variable calculations, so 3, and that'll tell us all the calculations for one variable. So it has a mean of 70, you can see that there. Okay, it has a standard deviation of 20. So I'll just fill that in down here. So for the last one there, we'll do the same thing again. All clear, all clear. Might be an idea to turn off the calculator, turn it back on just to make sure that everything's cleared. Okay, and then press menu. Statistics is what we're looking for, so press OK, or equals even. We want one variable calculation, so we put in one variable, which is 1. And then we just put in our variables. So we can put in these variables there. So we can put in 40, press equals, put in 70, equals 70, equals 70, equals 70, equals, the 6th value is 70, so we can see around the 6th value now, which is still 70. And the last value, or the 7th value, was 100, so we can put in 100 for the last value. Press equals, and that's our 7 pieces of information input. Now we want the calculator to do the hard work and do all the calculations that we spent the last few, we spent ages going through. So press shift, press options, or sorry, just press options and go to one variable, and it gives you all of your standard deviations and everything there, all your averages. Okay, so you can see there that it's going to be 16.0356. So 16.0356745. 1. Okay, so the standard deviations there are given, right? So now I want to show you what this actually looks like if we were to put it into the bell curve. So you can see here that this is, I'm going to take the first class. Okay, so if I take the first class, it has a mean of 70 and it has a standard deviation of 2. So it has a mean of 70, so I'm going to put the mean of 70 in. So 70 represents the mean, so the average is 70. The standard deviation is 2, so that means that this one here is going to be 70 take away 2, which is 68. This one here is going to be 70 plus 2, which is 72. This one here is going to be 68 take away another 2, so 68 take away a further 2 will give us 66. And obviously this one will give us 74 because we're going to add 2 to both sides. If I take away another 2, I get 64. And if I add another 2, I'll get 76. Okay, so this here represents how I expect the results to be distributed in class A. Okay, and you can see that the majority of the class are going to fall between 68 and 72. So the majority of the class, 68%, are going to fall between 68 and 72. 68 and 72. So you can see the majority of the class do fall in that bracket. Okay, and this is based on, this is going to inform, remember that this is just a sample out of the class of 30. So out of the class of 30, I would expect the majority to fall here. So these ones down here, so we've no data for 64, 65. So we've nothing in the 64, 65 bracket. But this is a sample that's going to indicate what I expect out of my class of 30. So I will be getting, it's most likely that there will be people who'll be getting 64, 65. That'll be falling in there. Similarly, there will be people that will be getting 75, 76. That'll be falling in here. There may even be people that get in the 80s or the 90s up here because there's 1% left for R. So that's class A. So I'm going to put that down there. So that would be class A. And that's how class A is going to look. Now I'm just going to represent class B. Okay, so class B had an average of 70 and they had a standard deviation of 20. So this went down to 50. This went up to 70, 80, 90. This went down to 30. This went up to 110. This went down to 10. And this went up to 130. Okay, now needless to say, there is no such thing as a result over 100. Okay, so these here are impossible, but this is just the way I'm expecting the data to fall. So that means I'm expecting a lot of people to fall in this bracket between 50 and 90. So the majority of the class in this case fall between 50 and 90. Okay, and there will be more at the lower end. There'll be very few at the higher end because it's limited. Okay, so that would be class B. So finally, this brings us to the last distribution curve for class C. Okay, so class C, we can see there that the mean is 70. So I'm going to put a mean of 70 in. Okay, and it has a standard deviation of 16. Okay, so we'll just round it off to 16. So if we had 70 plus 16, we'd obviously get 86. If we had 70 subtract 16, we get 54. So we'll get the next value there. So 86 plus 16 gives us 102. And 54 subtract 16 gives us 38. 38 subtract 16 will give us 22. And obviously 102 plus 16 is 108. 18 even. 118. Now, again, this is just representing that data. So you can see the majority of the class are going to fall in the middle bracket there between 84 and 86. Okay, so this is based on the 7 7 tests that I got, or the scores from the 7 tests that I got, this is how I predict the rest of the scores in that class to fall. So I would expect the majority of them to fall within 50 to 54 to 86, but there is more expected to have a lower result than there is expected to have a higher result, because obviously this is all over 100. There's no such thing as getting over 100. Okay, so that'd be my final distribution curve. So I hope this video helped. The whole idea was to help develop an understanding of what standard deviation is. But it's important, especially for leaving cert ordinary level. All you need to be able to do is you need to be able to input the information into the calculator to find the mean and the standard deviation of a set of numbers. Okay.